Hi grade 11s. Now that we've done basic trig equations, what we can start to do now is just to add subtle skills that we need in order to get to actually solving the equation. Now the good news is, even if you're not 100% sure on solving trig equations just yet, we practice the basic premise every single example. So I've called this level 2. So I'm just going to add in a couple of more interesting kind of steps before we get to actually solving the equation. So this first example we have here is the idea that it says solve for theta in the following equations, and the only reason this is different to what we have been doing is in the previous examples we just had cos theta equals, and it was given to us, whereas here cos theta is kind of attached to everything else. So this first example is designed to introduce the following step that we first need. In every single trig equation, you have to land up isolating your trig ratio. So the only difference between these examples and the example we did in the video 1 is the fact that the trig ratios were already isolated in the previous video. So all I'm doing now is requiring us to isolate the trig ratio first. Now these are linear equations, so they're actually really easy. So I would minus 1 from both sides, so I'd actually land up with minus 0.2, and then I would divide by 2. So basically it's like solving a grade 8 linear equation. So in this case I land up getting cos theta is equal to negative 0,1. And now we're back to a situation which was exactly like the first video. It's a cos equation. How do I solve it? Now hopefully you remember how to solve a cos equation. We do shift cos of the ratio, and with cos we remember that there's two different answers, and it's just the plus minus version of this shift cos. So in this case I shift cosed as if that's a word, but I shift cosed negative 0.1, and I got 95,739. Now I've left that decimal place, but ultimately I'm not doing anything with this theta now, and so I can round up to 2 decimal places, and so I actually get 95,74 degrees. Except there's two different answers. One's the positive version of this and one's the negative version of this. And then don't forget that you have to add K360, you have to do the surname. K is an element of integers. Now something I haven't actually said yet is this idea of what is cos allowed to be. So this is actually a really important concept which we haven't yet discussed. Don't forget that cos of any angle in the Cartesian plane is equal to x over r. Also don't forget now that r is always bigger than x, because if you think about it, anywhere you put an angle in the Cartesian plane, the x coordinate is this value there, and the r is basically the hypotenuse in the right angle triangle that you form. And so r is always bigger than x. That means that your denominator is always bigger than your numerator. So I've written that as a note to myself. My denominator is always bigger than my numerator. And if that is true, that means that x over r will always be a fraction, a proper fraction. So cos of any angle always has to be less than 1, because your denominator is always bigger. It also always has to be greater than negative 1, because yes, the x coordinate could be negative, but r is still a bigger number. And so this is really important. If you ever get cos theta equaling anything above 1 or anything below negative 1, there is actually no solution. And so that was revising our cos 1, and we've learnt the new skill, which is the whole point of this example number 1, is the fact that we have to isolate our trig ratio before solving our equation. So here's another example of where we need to isolate our trig ratio. This is a fairly easy one. So it's sine theta equals 2 over 3. So I've isolated my trig ratio. Okay, now how do we solve for answers with sine equations? Well, first of all, there's two answers, and in this example, because this is sine, you can't have them in one step. So I did shift sine of 2 over 3, and I got 41,81 degrees. However, your second solution for sine is you do 180 degrees minus shift sine of 2 over 3. So it's 180 minus 180 minus 41,81, which gives me 138 0.19 degrees. So I hope that rings a bell. So that's the way you solve a sine equation. You do shift sine. This is just shift sine of 2/3. And then the second solution for sine, because sine has an answer in quadrant 2, this is 180 minus the shift sine. And don't forget that we need to add on the plus k360. K is an element of integers in every line that you have an answer in. So the moment you introduce an answer, you have to have that. Now you're going to see in the long run, in the very next video, you're going to see why you can't just add that plus k360 in at the end. Now let's ask ourselves exactly the same question as we asked with cos. What can sine of theta be equal to? What is it allowed to be equal to? What is its range? Well, sine by definition is y over r. Now by exactly the same logic as with cos, x was always smaller than r in cos, and with sine, y is always smaller than r as well. Now why is that? Well, again, because if you think of any angle in the Cartesian plane, so even an angle like that, your y coordinate, you put in a little right angle triangle to work out x, y, and r. This is x, this is y, and that's r. And notice r is the hypotenuse of that little triangle. And hypotenuses are always longer. So therefore, exactly the same as cos, we know that a sine of an angle has to be less than 1. I should say equal to 1, because it can actually equal to -1. So let me go up there and change that as well. Cos and sine actually can equal 1 and -1, and we will get to that when we draw our graphs. But they have to be between 1 and -1 for both sine and cos. Because of the same argument, the denominator has to be bigger. Right, so we've practiced cos and sine. Let's practice a tan one. Again, I need to isolate tan theta. That's my first step, isolate your trig ratio. So I added 6 on both sides, and then I divided by 2. So I got -3. Now something that might shock you here is you're like, but sine and cos had to be smaller than 1 and bigger than -1. This is -3. So what is tan allowed to be? Well, tan, by definition, is y over x. And there's no rule about who has to be bigger, y or x. And so actually tan theta can take on any value, simply because x and y can be anything. Neither of them has to be bigger than the other. So that means that therefore tan, unlike sine and cos, tan theta can be any real number. So that's how we'd write it. Tan theta is an element of reals. It can be any real number, which is why in this example, I see tan theta equals -3, and it doesn't bother me. Okay, now, how do we find theta? Well, with tan is wonderful, because remember, tan was the only trig ratio where the first solution and the second solution are connected. So I did shift tan of -3, and I got -71,565, so 57 degrees, which makes perfect sense because a negative angle, that would be in quadrant 4, and tan is negative. This is a cos quadrant, so tan is negative there, so that makes sense. Now, how does this then link to the second solution? Remember, in every other trig equation solution, we write plus k360. Here, however, we write plus k180 because this links to the second solution. So you don't have to write down the second solution. It is automatically generated. And that's because, sorry, that handwriting is terrible. That says links to the second solution. I'll try to write better. And that's because the other solution for when tan is negative is in quadrant 2. And literally 180 degrees later, that angle occurs. And so that's why you can actually summarize both solutions in one line. Okay, so example 1 was all about isolating the trig ratio. So that's the skill we've learned. Now we need to move on to a different skill. Now this skill is all about what happens if the inside of the angle isn't theta, but for example it's 2 theta. We've been just doing sine of theta. Now this says 2 theta. So we're going to follow exactly the same steps as before. So for sine, I'm going to do shift sine. And in this case, it's shift sine of 0,3. And 0,3 is less than 1, so that's perfect. And so I get an answer of 17,4576 degrees. Now you might wonder why I'm not rounding off here, and I'll explain in a second. Now the important thing is, what is this equal to? And the reality is the angle that we were sining is not theta, it's 2 theta. So that's where this differs from our previous examples. So yes, theta isn't equal to 17,4576. It's 2 theta that equals 17.4576. Now, as I've said before, you've got to add in this plus k 360 degrees. K is an element of integers. Now, you're going to see exactly why. I actually didn't realize it was in this video, but right now we're going to see why you have to add in that k 360 in the first line. Okay, now this is my first solution. Now, I'm going to leave some space here because I haven't actually solved for theta, but very deliberately, I'm going to go and set up my second solution without going further, and I'll explain to you why in a second. How do we find the second solution? Is we say 180 degrees minus this 17,4576 degrees. Don't forget with sine, the first solution is shift sine. The second solution is 180 degrees minus this shift sine of 0.3, which in this case is 17 odd degrees. Now, you could actually do that in a calculator. There's nothing wrong with actually not showing me that step, but rather writing it on a calculator and just writing down the answer. At the moment, I'm writing it in because you're going to study from this, and then you're going to wonder where that came from. Now again, what's this equal to? This is equal to 2 theta. So 2 theta must have this value. And lastly, as I've always said, the moment you write down any solution, you've got to add on that plus k 360 degrees. And now we pretty much have our two solutions. The only thing is I need to actually solve for theta. So if I look at solution 1, for example, I don't need the 2. I want theta. So now I'm basically going to solve a little linear equation. Why am I dividing by theta? That's so silly. I need to solve for theta, so I'm dividing by 2. But don't forget, in an equation, when you divide by 2, you divide everything by 2. So divide by 2, divide by 2. So notice who also gets divided by 2. Now that's why you have to have that plus k 360 written in the first line, because otherwise we forget to divide by 2. So now I isolate theta, because my 2's cancel, and that equals, now this is why I keep 4 decimal places, because when you're going to divide by 2, those decimal places might kind of change things. So now that I've divided by 2, I get 8,73 degrees, and this is actually now plus k 180. K is an element of integers. So very important to remember that this also gets divided by 2. So very important, not only the angle gets divided by 2, but that plus that k 360 gets divided by 2. Now if I look at this next one, this has to do 2 theta equals, and if I just first do that subtraction before I divide by 2, I get 162,5423 degrees plus k 360. Because you've already stated k as an element of integers, you don't actually have to state it in each line, so I'm going to actually stop doing it because it's just annoying me. And now once again I divide by 2 and I divide by 2. So finally, oh, I forgot, divide by 2. I was just forgetting exactly what I just said we mustn't forget. So now when I divide by 2, I get 81,27 degrees, and this is also plus k 180 degrees. So where are our two final solutions? This is one of our final solutions, and here's the second final solution. Now I think one of the really important things that I'm going to say to you is always set this line up and this line up first, and then go and solve. The reason being is it's in order to avoid a problem. What a lot of people will do is they'll go and find this value for theta, and then for the second solution they will go and put that value in. So they'll say 180 minus 8.73. But that's not true, because I'm actually working with 2 theta, and so I mustn't use this value that's the value of theta. And so that's why I always say set up your two equations first and then go and solve. I always say that for everything. Even when we do cos examples, which is in the next one, set them up first, then go and solve. Okay, so far that was definitely the most trickiest. Let's look at the next one. Cos of 4 theta equals negative sine 20. Well, first of all, what is negative sine 20? That must be equal to something. So I'm going to go with negative sine 20 on my calculator, and my calculator tells me, and here I would keep quite a few decimal places, because every decimal place is going to change, and this is not the final answer, so I would keep quite a couple. Right, now how do we solve for 4 theta? Not theta, 4 theta. We do shifts cos, And this is where I'd absolutely use the answer button on my calculator. So I would go, because I've actually worked out this negative sine 20, I would go shift cos of answer. And what do you know? I get 110 degrees. So because I didn't round off, I get an exact whole number. Now we've got to just be careful. Why are there two solutions for cos? Well, one's a positive 110 degrees and one will be negative 110 degrees. So this is where our two solutions come in. And then I mustn't forget my plus k360. K is an element of integers. Now in this specific example, do I have to split this out now into the positive 110 and the negative 110? Sometimes you do, and we'll get there. But in this example, in order to just solve for theta, I'm going to divide by 4. So it doesn't matter if I have the plus minus all together. So this lands up with theta. Now, plus minus 110, when you divide that by 4, whether it's the positive version or the negative version, you still get the same answer. So I get 27,5 degrees plus k, and 360 divided by 4 is k90. Okay, so cos is quite a nice one because in this specific example, we didn't actually have to split into two different solutions. Now notice, I see I have forgotten to write my plus minus, so I just mustn't forget that. So it's plus minus 27,5 degrees. Now we will get to an example in the next video of where I am going to split cos into two separate solutions, because otherwise solving the equation for theta becomes problematic. But we'll get there in due time. Okay, let's have a look at question C. Tan. Tan is always my favorite because you don't have to worry about a second solution. So a half theta is what I'm looking for, and I'm just going to shift tan of 5. And I get 78. Again, I'm going to keep a couple decimal places because you never know. 690067 degrees. And don't forget that this is plus k 180. Now because that's 180, I don't have to write down a second solution. So that's both solutions rolled into one, except I don't have theta yet, so I need to times by 2. But don't forget, when you times by 2, you times everything, including the 180 by 2. So then I will get a value of theta, and now I can round off because it's my final answer, 157,38 degrees, and that'll be K360 now, not K180. So both of my solutions are wrapped up in that. Now here they didn't want a general solution. Remember, the solution that encompasses all possible solutions is called a general solution. They wanted all the solutions from 360 down to minus 360. So what we do is we start with the original. Is 157,38 acceptable? Yes, it is. And so I write it down. Now I pretty much know if I add 360, I'll get way over 360. So that's not going to work out. Why am I adding 360? Because always just be careful. In case they said I'm allowed to add K360. If that was K90, then I'd be adding 90. But this one said add K360 because I'd multiplied by 2. So don't just default to 360. You've got to look at what you're allowed to be adding. So I can't add 360 as I've already found out. But if I minus 360, I get minus 202,62, and that is acceptable. And now I can't subtract anymore because then I'd get too low. So there's two answers in this specific domain. Right, so on to our final question. This question is meant to summarize both skills we've learnt in this lesson. So what was the first skill we've learnt? The first skill we've learnt is to isolate the trig ratio. The first important thing in any equation is you've got to get that trig ratio by itself. The second thing that we need to do is we need to know how to isolate theta. So that's what we learned in example 2, and we're going to have to use it here because there's a 3 theta, and I'm going to need to isolate theta. So those are the two kind of techniques we learned tonight. Again, I'm saying tonight because I'm making this video tonight. Two things we've learned in this lesson. So first of all, we need to isolate our trig ratio. So these are separate terms, so be very careful. You can't do 2 minus 5 and get negative 3 because this is separate to the minus 5. The minus 5 is attached to the cos 3 theta, so that would be a huge issue. So I'm first going to subtract 2 on both sides. So I get minus 5 cos 3 theta will equal to minus 3. And now I would divide by negative 5. So now when I've isolated my cos ratio, I get cos 3 theta equals 3 over 5. Now I need to isolate 3 theta because that's the angle I was given. And I'm going to shift cos of 3 over 5, and I get 53 comma, and I'm going to keep a couple of decimal places because I know I'm going to land up dividing by 3. And don't forget that this is plus K360, and K can be an integer. Now where's the second solution for theta, or in this case 3 theta? Don't forget that this is either the positive version of that angle or the negative version of that angle. And so finally, this was the second skill we learned tonight. Gosh, I can't get that out of my head. The second skill we learned today, and that is dividing by 3, but I divide everything by 3. So when we say isolate the theta, basically what we mean is we divide by the coefficient of theta. But we mustn't forget to divide everything by that coefficient. And so I'll end up getting theta is, and I mustn't forget my plus minus, so plus minus, and this is now 17,71 degrees, and instead of having K 360, I get K 120 degrees. Now lastly in this example, this is pretty much combining everything we need to ever know. They gave me a specific domain. They said from minus 90 to 360. And now they want me to list all the angles. So let's start. Well, the first solution is positive 17,71, and that is in this range. Now, what would be the next solution after that? Well, just be careful. I'm allowed to add 120. So if I add 120 to that, and I'm just going to write here, I'm adding 120, I get 137,71, which is less than 360, so that's still okay. Now I'm going to add 120 again. And if I add 120 again, as long as I'm less than 360, I'm acceptable. And it is. It's 257,71. Now if you add to 120, it's pretty clear that you'll just be over the limit. And so I'm not going to add 120. However, I'm allowed to minus 120. So if I started there and I minus 120 degrees, what would I get? So 17.71 minus 120, and I get minus 102,29 degrees. Now, is that acceptable? Well, we had to stop at negative 90. And so you know what? That's not acceptable. So those were the 3 solutions that came from positive 17,71. However, the second solution was negative 17.71. So negative 17.71, which is in the range, is allowed. And I'm allowed to take negative 17.71, and I'm allowed to add 120 as many times as I like. So if I add 120, let me just write this in. If I add 120 degrees, I get 102,29 degrees. If I add another 120, because that seems like I could still add and be within range, I'll end up getting 222,29 degrees. And if I add another 120, I think I'm still within range. So there's quite a number of answers that work in this particular domain. However, I am also allowed to minus 120, but I learned fairly quickly with the 17,71. So with negative 17.71, I won't be allowed to minus 120 because I'll be too low. So there's actually, that looks like 7 solutions in this particular domain. So in summary, what was this lesson about? This lesson is about the fact that we've done the basics, and now we've added 2 additional skills that can be kind of needed within those basic solutions, which is isolate your trig ratio, which is actually a fairly easy linear equation idea. And then once you've solved for however many thetas, you need to isolate theta by dividing by the coefficient, remembering that you need to divide this plus K360 or plus 180 also by that same coefficient. Great. So slowly but surely we're getting there. Practice takes perfect though. Practice makes perfect.